Hey guys, this side Anirudh. I'll be your trainer today. So we have few sessions that we already gone through for BGP. So welcome to the next session. Let's go on.
Classless networking to BGP, then it is mandatory to define your mask value. But this time you know very well that it's not required anymore. 100, 101, 102, and finally 103. And then you can see IP BGP over here that we are having these 4 prefixes available over here at New York router. So it will advertise those. This New York router is going to advertise these 4 prefixes in the direction of BT, and then further BT will advertise it in the direction of Alpha R6 as well as Sprint US. Then definitely for Sprint US, its best path to reach all these prefixes will be BT. So Sprint will also tell to Alpha that you can also reach all these prefixes via me as well, right? So now because you have advertised all these prefixes at New York router, so definitely you must get them on all devices now where BGP is running. So here in this topology, I'm not running BGP on all routers. Let me show you that how have I configured, or how I have configured BGP in this topology, right? So I'll let you know, but before that, let me do some modification over here. Like on R5, it's showing me CDP duplex mismatch, so simply I will say no CDP run, and do show run pipe section router BGP, and it's using 65500. I have to remove some configuration from here, and this 56 as well. Only this configuration is available here on R5, that no synchronization is by default there in BGP, as I said earlier on. And the BGP log never changes. What does it mean? That it will generate a log message whenever a BGP neighborship will go up, or if it goes down. Then also BGP will give you a log message. I hope that you understand it very well, that what is the meaning by BGP log. BGP log never changes. Don't you understand the meaning of this command? Do you understand it? Sure?
Yes.
Dinesh, what's the meaning of it? Exactly, on the console of the device, right? Like this time you are accessing this device with the help of console cable. So whenever you will be having the console of this device, and then if your BGP neighborship goes down, then it will show you that message that neighborship has gone down with this neighbor. If BGP comes up, then also it will show you that message that with this neighborship have came up, right? So this time it is having neighborship with 1. This is the loopback of R1, and the loopback of this R1 is reachable via OSPF. As I have already explained you that internally we are running OSPF. So all routers are learning their loopback addresses with the help of OSPF, because OSPF 1 area 0 is already configured here among all devices. Hello, is there any problem? BGP is now also let you know how BGP is configured in this topology, but try to memorize that on all these devices, on all these 6 devices, we have configured OSPF, so that all devices are learning each other's loopback addresses, loopback networks. As you can also confirm it here on R1, show IP route. However, some routes will be there which are learning through BGP as well. But apart from it, see, these are the loopback address of all devices. Here we are having 6 devices, 1, 2, 3, 4, 5, 6, R1, R2, R3, R4, R5, and R6. And you can see that we are learning each router's loopback address with the help of OSPF, because OSPF is running as a internal routing protocol over here. Understood? So basically here on R5 we can see that this configuration is there. It means it is having IBGP neighborship with R1, and also it is having neighborship with 200.105.100.1, which is the BT's IP address. This is BT's IP address, 200.105.100.1. So R5 is having neighborship with BT as well as with the Sprint. This is the Sprint address, as you can see in your diagram as well. 205.100.100.10. Understood? Understood?
Yes.
Fine. Then after on R6, if you move on R6 also I have to do some modification in its BGP configuration. I have to remove command for R2. I have to remove command for 56.5 as well. Now it is also having neighborship. See, this R6 is having neighborship with R1. See, remote AS update source loopback is also configured. Next stop self is also configured because this is IBGP neighbor for R6, right? For R6, R1 is what? IBGP neighbor, and you know very well that if you are receiving prefixes coming from EBGP neighbor, and then if you are giving those prefixes to your IBGP neighbor, then definitely what? Next stop addresses will never get changed automatically. See, there is a rule in IBGP that if you are giving an update to your IBGP neighbor, then its next stop address will never get changed. But if you want to change your next stop address, you have two options, either with using next stop self, but next stop self command can be configured only on edge routers. And then after you can modify their next stop addresses with using their route maps. So this time it is also having neighborship with EBGP neighbor BT. See, this is the BT's address 201.100.100.1, as you can see here in this diagram as well. This is BT and its AS is what? 35500. See, this is the command. And right now we have advertised prefixes into BGP on to New York router only. I'm not advertising any other prefix on any other router right now. So only on New York router I have advertised all these four prefixes, which are like 100.0/24, 101.0/24, 102.0/24, as well as 103.0/24. Have you understood it now?
Yes.
Sure. Now go back to R1 and you see everything is fine. Now you do one thing. See, this time BGP is not running on R2, R3 and R4. BGP is not running on R2, R3 and R4. I have not configured BGP. That's why I said that logical topology will be quite different from this physical topology. Right now what is happening, that R1 is having neighborship with R5 and R6, both of them. R1 is having neighborship with R5 as well as R6. As you can see, you can move on R1 and you can check it out. Show IP BGP. So it is having neighborship with 5 as well as. It means there will be a black hole here, because routes of course can go from R5, R6 to R1, but those routes will not be available on R3 and R4. But actually I don't need to ping. I just need to show you that how can you manipulate your BGP path selection with using BGP attributes. I will not see ping, of course, will never happen over here. Ping will never be successful over here, because for that you have to run BGP onto R3 as well as R4. Otherwise there will be a black hole. Of course there is a black hole right now, because neighborship is there in between R1 and R5 and of course R1 and R6. But BGP is not running on R3 and R4, and also you have not redistributed BGP into OSPF. That is why those routes will never present on into the routing table of R3 as well as R4. But traffic, whenever you will transmit any traffic from R1 in the direction of New York router, it has to go through R3 as well as R4. So once they will reach, your packets will reach R3 and R4, they will get dropped, because R3 and R4 do not have route to reach your destination, right? So of course ping will never be successful, but we just need to perform path manipulation, and that can be done onto R1 without any problem, because R1 is receiving prefixes coming from R5 as well as R6. Now see, R5 is having neighborship. See, your logical diagram is something like this actually. This is your logical diagram of BGP. This R1 is connected with R5 as well as, then it is connected with Sprint, then you are also having BT. This R5 is having neighborship with both of them, and then Sprint and BT are also interconnected, and then further New York router is connected with BT. So this is your logical topology. This we are running BGP in this diagram, in this at the end of customer only on these three routers, R1, R5 and R6. So BGP is configured in this manner actually. This is your logical topology of BGP. Tell me. So this time R1 is receiving these prefixes coming from R5 as well as R6. Now try to understand it now. See, first of all, this New York router will advertise these prefixes in the direction of BT. Then for BT, its best path to reach all these prefixes will be via New York router only. See, you're on BT now. Check it out. Its best path is via 81.1.10, and who is having this IP address? This 80.1.1.10. Of course, New York router. So for BT, its best path is via New York router. See, what is the meaning by this asterisk? Valid. What is the meaning of this greater than symbol? Is what? Best. So you must remember the meaning of these symbols as well in BGP, right? So I hope that you people understand this. I mean, the meaning of these symbols were very well. Like, what is the meaning by asterisk and what is the meaning by greater than? So asterisk means it is what? Valid. Even though you can also find over here the meaning of these characters. Like, this is valid and this is what? Best. And this I is what? Internal. See, this I can be either in the beginning of the prefix or in the end of the prefix. So if this I is in the beginning of the prefix, it means it is an internal prefix. It is an means that it is coming from an IBGP neighbor. But if it is not there in the beginning of the prefix, see, like here it is not mentioned over here. It means there will be two possibilities. One, either it is received from its eBGP neighbor or it is self-advertised. There will be two possibilities in which you will never find I in the beginning of the prefix. First one is what?
BGP neighbor.
It is received from an eBGP neighbor. Second, self-advertised. As you can see, I is also mentioned in the end of the line as well. And if it is mentioned in the end of the line, it means it is specifying what? Origin codes. I have also told you before that if you are advertising anything into BGP with using network command, its default origin code will be I. However, here by looking at the meaning of this IGP, so it says that okay, if route is learned through IGPs, then it will be containing its origin code as I, but it's not true. See, in BGP, if you are advertising anything with using network command, by default its origin code will be I. And if you are redistributing anything into BGP, then by default its origin code will be question mark. And these origin codes will always be mentioned in the end of the line. As here you can see that it is always mentioned in the end of the line. Tell me. Is there any problem now? Sure. Good. So now if you move on R1, even if you check it on R1, see, for R1, both of them are IBGP neighbors, right? So IBGP, see, it is receiving these prefixes coming from R5 as well as R6. And in the beginning of the line, see, there is what? I. And also in the end of the line as well. So if this character is mentioned in the beginning of the line, it means it is an internal prefix, and if this character is mentioned in the end of the line, it means it was advertised with using network command into BGP by default. However, you can also modify your origin code as well. That's quite different thing. Fine. Hello, you people tell me, have you understood it or not? See, if this I is mentioned in the beginning of the line, in the beginning of the prefix, it means it is an internal prefix and also received from IBGP neighbor. And if it is mentioned in the end of the line, it means you understand very well now what I mean to say, right? So this time you can see that I'm on R1 and R1 is receiving these prefixes coming from R5 as well as R6. One more thing that I would like to show you. BT will advertise these prefixes now further in the direction of R6, R5 as well as straight. So of course for R6, its best path to reach all these prefixes must be via BT only. Fine. Then on R5, it is receiving these prefixes coming from, see, sprint as well as BT. See, if it is coming from sprint, then this AS 21545, see, 3 ASs are there. See, inside, this is called AS path list. Under path, it will be what? AS path list. Means that it will show you that this prefix has already crossed these following ASs. So in this AS path list, BGP will always contain, tell me what? All those ASs to whom it has crossed.
Yeah.
Right? So of course, remember that inside AS path list, rightmost AS will be originating AS. Will be originating AS. The rightmost AS in AS path list will indicate that this is originating AS. Means that actually prefixes are originating from this AS. Right? And the leftmost AS will be your neighbor AS. Will be your neighbor AS. So this time in neighbor AS you can see there are two ASs. One is 21545, which is configured on sprint. I mean sprint is using this AS. So if you are getting prefixes, if you are receiving prefixes here from sprint, then definitely the leftmost AS will be 21545. And also you are receiving these prefixes coming from BT as well. And from BT, of course, it is what? 35500. Fine. Okay. Now, as I said that whenever you will receive any prefix, okay, forget about all these things. Now, let's start it from R1 itself. See, for R5, it will define its best path. So, for R5, which path is the best path here? Via BT. Because via BT it has to across only 2 ASs, whereas via sprint it has to across 3 ASs. So its best path is via, yes, tell me. Who? R5? R5 and R6 do not have BGP pairing with each other. See, this is your diagram now. Fine. So R5 and R6 do not have direct neighborship with each other. R5 and R6 are having neighborship with R1, IBGP neighborship with R1 only. And R1, of course, by default in BGP there is a IBGP rule that if you are receiving anything from your one of the IBGP neighbor, then you will never advertise it towards any other IBGP neighbor. So that definitely R1 will be receiving prefixes coming from R5, but will never advertise it in the direction of R6. And also if it is receiving anything from the R6, then definitely it will never advertise it in the direction of R5. Have you understood it or not? Great. Now let's move back again on R1, and you can see here. And remember that BGP will always advertise only and only best path information. That is why here it is receiving this information from R5 that you are required to across only 2 ASs, not 3 ASs. Because for R5, its best path was via BT only. See, this is the best path for R5, so it is advertising only and only best path information. See, in BGP, this feature is contained from distance vector routing protocols, that it will advertise only and only best path information towards its neighbors. So for R5, its best path is via BT. So only this best path information is propagated from R5 in the direction of R1. Check it out. And from R1, which path is the best path? Via R5. As you can also see, so if you route via BGP, see, for all those prefixes which have learnt here via BGP, its best path is via R5, not via R6. That's completely incorrect. Now, in terms of R1, I will define you, or I will teach you that how to perform path manipulation in BGP, right? I will start from very scratch. I will start it from next hop address configuration first of all, right? And then I'll go for some other things, some other configuration. Fine. Just yes, guys. For R1, its best path is via R5. So first of all, I'll teach you that why R1 have selected its best path via R5. Fine. So let's start it now. So IP BGP. See, this is your one path, and this path is coming from R5 as well as R6. The very first thing that is checked by BGP is that whether this path is valid or invalid. So both of them are valid. See, this is. Then second number will be next hop address. Why R5? Its next hop is what? The loopback of R5. Why R6? Its next hop is what? The loopback of R6. Because I have configured that next hop self command onto R5 as well as R6 for their neighbors, for their neighbor R1.
Validity the next hop के base पे होता है.
No, sometimes it is not like that. I'll let you know later on that in which conditions it will not be valid actually. See, if I move back again on R5 and see, this is the existing configuration of BGP onto R5, right? And this is router BGP 65500. Now I'll simply remove this next hop self command from here. And in same manner, I will move back again on R6 and let me show you the existing configuration of BGP onto R6. And onto R6 itself, what will I do actually? 65500. I will remove this next hop self command only. After removing these two commands from R5 as well as R6, now let's move back again on R1. So if you are on R1 now, you see next they are valid paths. I mean, these prefixes are valid, but they are not best. So basically, this valid or invalid will not be depending on your next hop address. Remember all these things, right? So still these prefixes are valid but not best. I'll let you know later on that in which conditions even your prefixes will not be valid prefixes, right? So I will teach you all these things as well. But this time you can see that due to next hop reachability, it's not, I mean, no one is best. Now, if you move back again on R6, this time I'm on R6, right? Router BGP 65500 for their neighbor, I mean for its neighbor 150.1.1, I will say next hop self. Once you will configure this command onto R6 now, you see its best path have been configured via R6. So what is it checking first of all? Next hop address. See, this time via R5 it's not participating in best path selection. You know why? Because its next hop address is not reachable anymore. Even you can also try it to communicate with 200.105.100. Of course it's not reachable from here. But if you try to communicate with 150.1.6.1, it is reachable via OSPF, because internally I am running OSPF and this is the loopback address of R6. Even I have configured BGP peering between R1, R5 and R6 with using their loopback addresses only, right? So now you do one thing, move back again on R5 as well. Say router BGP 65500, and as you remove from here this next hop self command, now once again reconfigure this next hop self command here onto R5. Now move back again on R1 and check its BGP table. See, see,
जब नेक्स्ट हॉप जब रीचेबल ही नहीं फिर उसको वैलिड क्यों रहता है?
मैंने कहा ना, मैं बाद में बता दूंगा किस केस में इनवैलिड होगा. अब वैलिड के पीछे पड़ जाना बस. So I hope that you people have understood all these things, right? So see, once again its best path is via R5. Now question is that why has it defined its best path via R5. Like for R5, its best path was via BT. Reason was AS path. Because via BT it was required to cross only 2 ASs, whereas via sprint it was required to cross 3 ASs. So R5 defined its best path via BT due to AS path attribute. But this time, if you move on R1, its best path is via R5, and you have to identify it that why has R1 defined its best path via R5 only, not via R6. First of all, you will check what? The sequence. In sequence, tell me that what will you check first? The very first attribute is what? That BGP checked first. Next hop reachability. So of course, via R5 as well as R6, its next hop addresses are reachable. Next is what? Yes. Wait. After next hop, it is wait that you will check first, right? So I have also defined you that in which sequence BGP will check its attribute. Don't go for that. I mean for the categories of attributes. Check it out. Where is it? Next. Where is that? You didn't mention it here.
Next stop is.
See, first of all, it is wait. Next is what? So, okay, first of all, let's talk about the wait. See, as I told you,
Wait.
that first of all, it will check its weight, and for all received prefixes, by default, its weight will always be 0. So, YR5 as well as YR6, its weight is what? You can see here. So, based on weight, it is not going to decide its best path now. After weight, it was local preference. Fine. Higher is always preferred, but you can see for all internal prefixes by default its local preference will be 100, and here you can see that by default its local preference is 100. Check it out.
Yep.
And because its default local preference is 100 via both neighbors, so of course it is not going to define its best path based on local preference now. Next attribute was
Self-advertised.
it is not self-advertised. These prefixes are coming from its neighbors only, right? Is it self-advertised from R1?
No.
Of course no. It is received on R1 from its neighbors R5 as well as R6. Next is what?
AS path.
AS path. Now it will calculate total number of ASs available inside their AS path list, and here you can see that via both neighbors it has to cross same number of ASs. Is not it? It means R1 it will not be able to define its best path based on AS path attributes. So that's why it have not elected its best path yet. Next is what? IGP codes. I mean origin code. Don't say IGP code, say origin codes. So via both neighbors its origin code is what? I, which is again equal. It means that based on origin code again this BGP is not going to define its best path selection. Next is what? Med. Higher is always lower is always preferred. Lower is always preferred, and by default for all internal prefixes it is what? 0, as you can see here. By default it is 0, and if it is 0 via both neighbors again based on med, it will not be possible for BGP to define its best path. Next is what?
IGP cost to reach.
IGP cost to reach?
Next stop.
No, it's not. Before that we are also having external is always preferred over internal. But this time you see that I is mentioned via both neighbors. Check it out. In the beginning of the prefix. In the beginning of the prefix I is mentioned, not in the end of the line. In the beginning of prefix itself I is there. It means it is an internal prefix which is received from an IBGP neighbor. So this time this R1 is receiving these prefixes coming from an IBGP neighbor. That is why this I attribute is there. I mean not I. Yes, of course it is I origin code, right? This is IGP origin code, right? Via both neighbors. So because via both neighbors its origin code is same now, will it be possible for BGP to define its best path based on origin code now? No. Next attribute will be wait. After origin code I taught you external internal actually. Okay, after origin code it was med, and then after med I taught you external internal. So for external internal you will not see that I which is in the end of the line. No, you have to see that I which is in the beginning of the prefix itself. So if there is I in the beginning of the prefix, it means it is an internal prefix. It is received from an IBGP neighbor. So via both neighbors there is I, because both of them are IBGP neighbors. So this time R1 is receiving this prefix from an IBGP neighbor. That is why based on external and internal, it will not be possible for you to define your best path. Hello, this time this router is not defining its best path selection based on external and internal. Next is what? IGP cost to reach next hop. Now there will be two conditions. Either IGP will be running over there or not. It's not it. So this time you are running IGP, I mean OSPF. This time the meaning by IGP cost to reach next hop address is the actual IGP cost, actually, like OSPF or EICRP or RIP, whatever it is, right? So this time we are running here OSPF to reach next hop addresses. So what is the cost to reach the loopback of R5 and what is the cost to reach loopback of R6? To see that, you do one thing, says to IP BGP 100.0, so that it will show you detailed information. Now it will show you it will show you information, it will display information in more details. See, via R5 its metric is what? To reach this R5, and to reach R6 its metric is what? So its lower metric is via
R5.
That's why its best path is now via R5. And if you
Thank you so much, guys, for watching my video. So we'll be coming back with few more videos of the BGP. Please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you in next video.